Hello everyone and welcome to Mathematics, which helps you to practice the habit of completing a question a day in mathematics. For this video, we'll focus on Chapter 3, Integration, and let's aim ourselves to learn two things from this video. So I'll let you have a few seconds to go through the question first. So before we begin, I'll let you all know that I will use colors to differentiate these two equations so you'll be able to understand better. So for part A, we need to find two things. One is the coordinates of B and the area of the shaded region. So to find the coordinates of B, we can use substitution. We can either select either one of the equations and sub it into the other one. So let's say I sub the red equation to the blue equation. So I factorize y squared out and we can separate this into two equations. And our answers are y equals to 0 and y equals to 1. And we need to reject either one of it because our point B is in the middle of the diagram. So it wouldn't be y equals to 0, hence we reject it. And we use y equals to 1 to find the value of x. So the coordinate of point B will be 1, 1. So for integration, these kind of finding coordinates questions would be useful for the future questions because it helps us to determine the limits of the integral, which helps us to integrate from which value until which value. So make sure you score well because it's the most easiest part, and also it plays a big role for the future questions. And for the second part, we need to find the area of the shaded region. So this is one of the aims of this video, which is using integration, find the area. So to find the area of shaded region, I always tell my students to first find the big shape, and within that big shape, minus out the unnecessary or small parts. So for this question, we actually have two ways. Either we are using the x-axis or the y-axis. So here, x-axis means to find the area, I will just go to here, stopped by the x-axis. I wouldn't go beyond the x-axis. But the easier way would be the y-axis, so I'll teach you all the y-axis way first. I will choose the equation which is further away from the y-axis, which is the red one, and I will find its area under the curve, which is this part. As you can see, it includes the shaded area, but at the same time includes the unnecessary parts. But this unnecessary part is actually our blue line's area under the curve, which is this part. So by minusing off the red shape, which is our big shape, minus out the unnecessary parts, which is the blue shape, we can find the area of the shaded region. And now to find the area under the curve, we need to integrate these two equations. Since we are using the y-axis way, so outside of this integral, I need to put dy, which means I need to integrate x. So our red equation, x is actually y squared. And our limits, we can look at the y-axis, so it starts from 0, but it ends with the y coordinate of point B, which is 1. So this is the usefulness of part A1. And for the blue shape is also the same thing. dy put outside, integrate x, so x is y cubed, and the limits are the same as previous, which is 0, 1. And remember, when integrating, we need to add 1 to the power, and we divide with the new power. And later, we need to sub 1 and 0 to this to find the value. Same goes to the other equation. And you'll find the value is 1 over 12 units square. So for the x-axis way will be the same thing. We need to find the equation which is further away from x-axis, which is the blue equation. So I will find its area under the curve, which is our big shape. And we minus off the unimportant parts, which is also the red equation's area under the curve. So for the integration part will be a bit different because we are using the x-axis. So for the integral outside, we need to put dx instead of dy. And we need to integrate y. So for y, our equation does not have it, so we need to rearrange this equation. Same goes to the red equation, and we need to find our limits. So the same thing, it starts from 0 and ends with 1, which is the x coordinate of point B. So by integrating and subbing in the values, you will get the same result as the y-axis way, which is 1 over 12 units square. And for part B, we need to find the volume generated in terms of pi for this region bounded by these 3 lines. And we need to revolve it through 360 about the y-axis. So here's the second thing we need to learn from this video, which is to use integration to find the volume generated. Before we find the volume, let's determine what is the region. So firstly, I would draw this line out by using these 2 points, the intercept and also the x-coordinate of point B. So our region would be this outside curve, this straight line, and the y-axis. So here's our region. So to find the volume generated, I always tell my students to first view this question as finding the area of the shaded region. So what I will do is I will separate this region into 2 parts from point B. And you can see that this is a triangle and this is the area under the curve. And now we transform these 2D shapes into 3D shapes by imagining these shapes rotating around the y-axis. So if we rotate the triangle, you can see that from this video it becomes a cone. And for this area under the curve, it would be similar to the lower part of gassing. But we don't need to worry about this because we can find this volume generated using integration. Like we are finding area under the curve. So for the first shape, we use the cone equation, which is 1 over 3 pi r square. So the r would be this length, which is 1. And for the height is also 1 from this diagram. And to find the volume generated by this area, we have a formula. So we need to multiply pi first, and we need to integrate depending on which axis we are rotating. So here we are rotating y-axis, so outside we need to put dy, and inside we need to put x, but remember we need to add a square. So for this equation is x equals to y squared, so x squared would be y to the power of 4. And our limits would be, according to the y-axis, it starts from 0 and ends with 1. So and by integrating and subbing in the values into this expression, you'll find that the answer is weight over 15 pi units cubed. And with that, we have completed today's question. So here are the 2 things we need to learn from this video, which is to use integration to find the area and the volume generated. And here are our take-home points. So to find the area, the practice is to first find the big shapes and we minus out the white or unnecessary small shapes. So usually the shapes involve area under the curve, triangle, rectangle or trapezium. And to find the volume, we view the question as we are finding the area. And using our imagination, we rotate the shapes to become 3D. So if we rotate triangle, it will become cone, and for rectangle, it will become cylinder. For this one, we'll explain more detail for future videos. Right, so here's the answer scheme for this question, and hopefully you have learned something new from this video. So if you feel this video is beneficial to you, please give a like, subscribe and share. So I'll see you all very soon in the next video. Thank you.